succeed on the test and or we're not successful with on the test, and then move on. So which problem would you like to start with? I was expecting better results. I was expecting this not to be a problem 4, but it was. I was expecting problem 5A not to be a problem, but it kind of was. This gave a little bit of a problem, and we did very similar problems in class. I just changed tangent inverse from cosine inverse to tangent inverse. Everything else was the same. This one, I did not see you finishing it correctly. And we did several in class with lowering powers. Okay, so let's start with whatever you want. And I think today is the 27th. We agree, we disagree. Okay, so what do we start with? Any questions on problem 1? Let's start like that. Any questions on problem 1? Do we know? Is okay? Is one okay?
Yeah.
Okay, problem 2. Are we okay with problem 2? If you did not get 6 out of 6, we're not okay with it. Are we okay with number 2? Okay, let's move on to number 3. Anyone? Anyone number 2? Okay, number 3. I was not happy with number 2. So this is log base 3 of 2x to the 4th. This is not the 4th root, but I accepted it. I think Chris did. He thought that 4 was the 4th root. I'm okay with that. If you saw that and you used it and everything else is correct in the problem, I give full credit. Although it was x to the 4th times the square root of x minus 1 over x plus 4 times 2y minus 1 to the 3rd. But if you did it correctly with the 4th root, I'm fine. But it wasn't done correctly, though. Let me see. Did you change it so you had 2x? Or you had a 4 in front?
Yeah, I just changed to 1 over 4.
Okay, but you didn't put the 1/4 in front.
No.
You have to.
Yeah,
You have to use that.
And
And you did not change. This is correct then. Now this is correct. This needs a 1/4 in front. This needs parentheses, and we don't do that. We just put the 3 in front.
Yeah.
That's one of the rules.
Yeah.
Okay. Okay, I consider that correct. Okay.
This was a doozy. Not gonna lie.
Okay, well, what I said before you showed up, we are going to have an extra credit for this test with test 4.
Okay.
Okay, so an hour will be test 4 and an hour will be from this. So you can get away from this part, okay?
I need that. Yeah, I need the extra credit.
Okay, I need the extra credit too, otherwise I'll go home crying.
Well, I told you this is chapter 7 was a doozy.
Okay, so is this clear so far? Okay, so now if you remember, we said log base 3 of the top minus log base 3 of the bottom. Is this okay? I have to address the ratio first. Ratio first. There are only 3 rules, right? Log applied to a product, log applied to a ratio, and log applied to a power, an exponential notation, correct? Okay, so first I have to apply the quotient rule, and I did. But now look at this very important issue here. Whatever I write after this, it has to have a negative sign. Whatever this becomes to be, all the terms will have negative in front because I have to distribute that negative. Okay? If a quantity comes from the denominator of a log, inside a log, not the denominator of log over, right? If anything that is here in the denominator inside the log will have a minus in front. Mandatory. Anything that comes from the top of a log will have plus in front of the log. Okay? Is that okay? So now I have, here I see 3 factors, 2x to the 4th and the square root of x minus 1. So I have to have a sum of 3. Log base 3 of 2 plus log base 3 of x to the 4th plus log base 3 of the square root of x minus 1. It's the product rule. We agree?
Yeah.
Now here I have 2 factors. They come from the denominator. I will have to distribute a negative sign. So log base 3 of x plus 4 is incorrectly written. This says only log base 3 of x plus 4. Remember, you have to use parentheses. Okay, and then minus log base 3 of 2y minus 1 to the 3rd. So we are done with the ratio, quotient rule. We are done with the product rule. The last step is the power rule, if the power rule is applicable. In the reverse way, right? So the first one has no power. The second one has a power. So I copy log base 3 of 2 plus, right, log base 3 of x plus, yes, 1/2 log of x minus 1. If I omit parentheses on x minus 1, I mess up the whole thing.
I thought 2 and the x are together. That's where I missed it.
Okay, that's okay. But it's a product. 2x is a product, right? Okay, that's okay. Minus log base 3 of x plus 4. And minus the last one is?
3 log.
Yes. Base 3 of 2y minus 1. Is this okay? Okay. Moving on to problem 4. I was disappointed. So this is a function, f of x, which is natural log of x minus 1 over 2 minus x. We're asked to find the domain of this function. I have to present the restriction. I can't give credit for something done with a calculator and something in there. So, no. You are right, but we can't get that far yet. So, I have log applied to a quantity. What do I have to, what is the condition that the quantity has to fulfill? Otherwise, it cannot be inside a log.
Greater than 0.
Excellent. So, x minus 1 over 2 minus x is greater than 0. Excellent. Now, I have to go back to chapter 1. I have to dig deep and say, what is this? It's not linear. It's not quadratic. It's not polynomial. It's not absolute value. What is it?
Rational.
Rational inequality. This is a rational inequality. Excellent. How do I solve a rational inequality? Okay, let's go back to chapter 1.
Oh, you need to multiply.
Nope, I cannot. Not in exactly. Okay, well, I'll look at it. Maybe I made a mistake. It's possible. I hope I made a mistake, okay? So, x is the variable in the problem. X minus 1 is the first factor. 2 minus x is the second factor. And then I have x minus 1 over 2 minus x. This is what I'm interested in. Okay. I know the variable goes from negative infinity to positive infinity. When is the first one 0?
1.
At 1. When is the second one 0?
2.
At 2. So all I need is 1 and 2. Not negative 2, not positive 15, nothing. Just negative 1 and 2. Okay, where is 0?
1.
Very good. Where is this 0?
2.
2. What happens to the fraction when the top is 0?
0.
What happens to the fraction when the bottom is 0?
Doesn't exist because
What is the sign of the first one? Is it this or is it this? Good. So what is the sign? Or just plug in numbers. What is the sign of this? Right, because it has a negative leading coefficient. If you don't like it like this, always write it in the appropriate order. Okay, when I divide these two, what sign I get? When I divide these two, what sign I get? When I divide these two, okay, so then what sign do I need? Good. So x is in the interval, or if you don't like this, the domain is we cannot forget how to study the sign of an expression. It could be rational, it could be polynomial, but we have to remember this. Now, I agree if you use a different method. I'm fine. Here's a different method if you like it. I prefer this one because it's visual, but you can, and it's the other method has a flaw. I shouldn't even present it. The other one has a flaw because it will not tell you when to pick the endpoints of the interval. Are we okay with number 4? Yes? We understand our mistakes? Okay, perfect. Now number 5. We had several examples like this. And yes, I did say that this is the most difficult one. Because we are asked specifically not to use approximations. We have to do everything algebraically. I saw that. So if I apply natural log, because I cannot present 4 and 3 with the same base, right? If it were 4 and 8, I would have not applied the natural log. Because it's much easier if I don't, I think. But you will get the same answer if you do apply natural log, even if both can be presented with the same base. But in this case, there is no other way, correct? Now, not even one of my precious students here put parentheses around that 1 minus x. Maybe Chris did. I'm not sure. So I need to write this. If I don't write this, I will not distribute. I will only have x times natural log 4, but not distribute to the 1. So this is 2x plus 5 times natural log 3. This is the rule. Whatever the power is, that entire power becomes a factor in front, not a term, a factor. So it has to be in parentheses. Do we understand this? Okay. Now I have to distribute. And I have natural log 4 minus x natural log 4 equals 2x natural log 3 plus 5 natural log 3. Then, and I remember Parker asked me, why do you move terms around and blah, 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 a long time ago. When we were studying this, it was a very legitimate question. Why? Why do I move terms around? It's because this has x and this one doesn't. So then I have natural log 4 minus 5 natural log 3 equals x natural log 4 plus 2x natural log 3. So I have the variable entirely on one side and the numbers entirely on the other. But now what do I do? Because I want to solve for x. What will be my next step? Yes, but can I? Excellent. But in the back of my mind, I know what algebra and pre-calculus and calculus are all about. Or? Exactly. So simplifying factor, this should always be in the back of our minds when we do anything here. So if I can simplify, then it must be factoring. And what will I factor out? Exactly. That's all I need. That's all I need to solve for x. Just notice that 2 terms have x in them. Pull out the x and what I have in parentheses. Excellent. And now I'm done. Yes, I had 4 steps to go through, but I get x. How much? What do I write?
Negative 1.44.
That does it. That really does it. Okay, so what do I write?
Uh,
That was the rounded, 1.14 is rounded.
Yeah, it's not the full answer. I tried to math bracket and make myself look, but it didn't fraction out.
I'm gonna have to chase you around the block. See who's faster. Okay, so then, what is it?
Oh, x equals.
Stop torturing me.
Natural log of 4 plus.
Finally. Over?
Is that
I know, you don't understand my handwriting. That does it too. Okay, is this clear? Every step. You're gonna see this again.
Oh, so you subtracted.
This is linear in x.
Okay.
So when I move negative x natural log to the other side, it becomes positive. When I move 5 natural log 3 to the other side, it becomes negative. These are just two numbers. Don't even bother. Don't even look at them. Just ignore them. Here you have x in two terms. You have to factor out x, and you have two more numbers in there. Ignore them. Just numbers.
How did you get to that answer?
So if I have 10 equals x times 5, I divide both sides by 5.
Oh, wait. Oh, you just did not.
Right. Is that okay?
Oh, okay. Yeah.
It's linear. I know it looks interesting. It's not. It's just a linear equation. Okay, moving on. What about part B? What does that mean?
What? Honestly, I plugged that one into the calculator.
Okay, so we have log base 8. I treasure honesty. I really do. Okay, this is a log equation. Remember, there are two conditions here, two routes. Either I find the domain, which you started very well, or I check at the very end. But one or the two has to be applied. I either stay domain or check at the end. Which one is it? Which one do we want to go? Okay, which means x plus 5 is greater than 0, and
X minus 2.
right, this one says greater than negative 5, and this one says greater than 2. You can graph them to see where it's going, what it's going on here. So from negative 5 to infinity, and from 2 to infinity. I have to choose where I see both colors, blue and red, because both logs have to exist for the solution I'm going to find if the equation has any. So where is the overlap? It's not in your pocket?
Oh, sorry.
No, I'm just kidding. So the domain is?
2.
Do we all agree with the domain? Okay, now I will condense. Everyone, almost everyone, I think everyone condensed it correctly. But then the whole thing went downhill.
So log 8, x plus 5 over x minus 2.
Good. And then we know that any log equation, we learned in this chapter, any log equation can be replaced by?
8 to the first.
Right. 8 equals x plus 5 over x minus 2. But never forget what we discussed a long time ago. It's a proportion. Right? Good. So what do I write? 8x minus.
Minus 16.
Yes, equals x plus 5. I subtract x. I add 16. So the answer is it here? Because if it's not, I have to cross it out. Yeah, that's it. Not sure how you got a quadratic equation. I'm not sure what happened there.
Why
Did I do something?
No, I was going to say, why not lose a point on Or is that only the time?
No, because you wrote 1 instead of 8. So I'm not sure how you got that.
Okay.
It's 8, right? It's not 1. This does not equal 1.
Oh, I think okay, yeah, I don't know how.
Okay. Problem 6. Do we have to work on problem 6? I think everyone got 6, but it's okay if you are not sure about something. Do we?
Yeah, can we do that one? Sorry.
6?
Yeah.
Yes, of course.
I just needed to. I couldn't remember how to get that.
But remember, I said if you get stuck on a formula, you don't remember formula, ask
Well,
me.
I had the formula. I couldn't remember how to get the coordinate.
Okay, so there are 2 formulas here. It's either the number
Yeah, I had that.
or the mass. They are identical formulas. However, one of them is doing this, which is the growth of the population, and the other one is doing this, which is the radioactive decay. Because this negative power brings 1 over e to kt. That's why. Okay, that's why this is decreasing and this is increasing. But the formulas are the same otherwise. Okay, perfect. Which one am I going to use? Am I going to use the first one or the second one? Yes, for populations, we use the first one. Okay, perfect. The stray cat population grows exponentially in a small town. In 1999, the town had 30. So that is the number N0. And the relative growth, which is K, is 0.15, 15%. All I have to do is plug it in. In part A, n of t equals 30 e to 0.15 t. Done. Part B. Find the exact population after 4 years. N of 4. We just plug it in. 30 e to 0.15 multiplied by 4. How much did you get, Shane?
54.6.
Good. So I can't have 54.6. I can't have 55. I would say 54. I accept 55, but when it comes to people, cats, rats, we can round up, right? Because 54.6 doesn't mean that we have 55. Okay, so 54 cats. But it's okay. Mathematically, I understand. Find the number of years required for them to reach 500. So what do I do in part C?
That equals 500.
Right. So I have 500 equals 30 e to 0.15 t. We know how to solve this, but first we have to clean it up. How do I clean it up?
You divide by 3.
Right. So first I have 50 divided by 3 equals e to 0.15 t.
And you multiply each side by natural log.
Yes, I apply the function to both sides, yes.
And then that e goes away. And then just divide by 0.5.
Okay, approximately how many years?
18.7.
Okay, 18.7 years. Do we understand every step? Yes? Parker, is this okay?
Yeah.
Any questions? Any questions on this?
Number 7. Can you go over how to
Yes.
use the
Yes, of course.
the point, like the 0.375?
Exactly. Yes.
I did it backwards because I was like, oh, 20 goes.
That's okay. Is this okay now?
Yeah.
Every step, every part?
For some reason, I rounded 0.15. That's why I threw off all my.
Right, but I'm not sure why. 0.15 was given. You're not asked to find it. Okay, that's okay. Very good. So in problem 7, we have the half-life is 4 days. After 20 days, a sample has been reduced to a mass of 0.375 grams. So this is 1 point. So in 20 days, the sample has a mass of 0.375, right? So 20 days, comma, 0.375. Also, 4 days, comma, the initial mass over 2. That's the other point. So I start right now with an initial mass. I don't know what it is. It's M0, unknown. What will happen in 4 days? How much will I have in 4 days? Whatever I have over 2. Is that clear? Yes? Okay. So then I start with this point. Which formula do I use? We have to establish which formula we use. Which model?
Oh,
It's m of t equals, right, m0 e to negative kt, right? Okay, so let's use the first point, and please tell me what I need to replace where, how. What do I replace this by?
20.
Okay. Not this point yet.
0.375.
So what do I replace this by? I'm only using this point. What do I replace this by? It's the y value, so I shouldn't have any difficulties with that. Exactly. This is m0, this is e, I do not have k, and what is this? Exactly. That's the first point. When I am told the half-life is blah, 5, 10, whatever, 10 million, this is the point I write. Half-life, comma, the mass over 2. In the model, I only plugged in this point. When time is 4, the mass is m0 over 2. That's what 4, comma, m0 over 2 says, correct? It says when time is, the y is this. Is this clear? Okay, because I have two variables here. I don't have the initial mass, and I don't have the radioactive decay rate. So I need to establish, I need to find these two. I cannot plug this point in at this point. Right now, I cannot use this. I can only relate to the half-life. So I'm told one more time, 4 days later, I have half of what I started with. And this is what I plugged in. How do I solve this, and for what? Exactly. I divide both sides by m0. So I have 0.5 equals e to negative 4k. This is my only chance to find Thank you. What do I do next?
Natural log.
What do I do next? Negative. So then k is, I plug in the calculator, and I get natural log 0.5 divided by negative 4, and I have 0.1733. Remember, we need 4 digits. So 0.1733. I accepted 3.2 or something like that, but that's the correct. Okay. So then for now I have m of t equals m0 e to negative 0.1733t. Now I'm ready to use this point. What am I going to do with this point? I should have presented this one. So right here, this point. What will this point help me determine? Exactly. So please tell me how to plug this point in this model. What do I replace and where?
The So that's going to be 0.375.
The left-hand side, 0.375. This is m0 e to negative 0.1733 multiplied by, exactly. When t is 20, the mass is 0.375. This is a linear equation. I will determine m0 by simply dividing this by this. So 0.375 divided by e to negative 0.1733 times 20 if you want to put it like that. So I go to the graphing calculator. And I have 0.375 divided by, I like parentheses everywhere. Okay, parentheses again, negative 0.1733 multiplied by 20, close, and close the other parenthesis. I don't need that second set, but you know me already. Okay, so this is 12 grams. So m0 equals 12 grams. Finally, we have the entire model. No secrets anymore. And now if there is anything else, then I can answer. So what was the initial mass? 12. Find a function that models the mass remaining after t days. Right here. That's the function, part B. What is the mass after 3 days? Plug 3 in. Exactly. So m of 3 equals 12 e to negative 0.1733 times 3. And I go back to my calculator and I have 12 multiplied by e raised to, in parentheses, negative 0.1733 multiplied by 3. And I get 7.135 approximately. 7.135 grams. After how many days will only 0.15 remain? Sorry. After how many days only 0.15 will be left from the initial of 12 grams? How do I address this? So how do I start? What do I write? Exactly. Equals 12e to negative 0.1733 times t. I can't apply log. I have to clean it up first. How do I clean it up? By? Right. So 0.15 divided by 12 equals e to negative 0.1733 t. And I have no choice but apply log to both sides. So this is natural log 0.15 over 12 equals negative 0.1733 t. And t equals natural log 0.15 divided by 12, negative 0.1733. And how many days? So natural log 0.15 divided by 12, and everything divided by, in parentheses, negative 0.1733, close the parenthesis, and I got 25 days, 0.3. A little bit more than 25. If the mass gets half every 4 days, you can imagine. Okay, problem 8. Do we need anything in problem 8?
We need to do just the cosine x divided by 2.
Yes. Yes. So first of all, sine 2x, I need to work on this together with you on everything. However, because you missed to find the quadrant for sine 2x. Okay. So sine 2x is 2 sine x cosine x. And cosine x over 2 is plus or minus the square root of 1 plus cosine x over 2. So these are the only two formulas we need so far. Okay, we're given only this as being 3/5, but for an angle in the third quadrant between 270 and 360, which is in the fourth quadrant. Very good. So this is positive. Therefore, sine must be negative. Okay, so then sine x will be negative the square root of 1 minus 9 over 25, which is 25 minus 9, which is 16. So this is negative 4/5. So this is negative 4/5. So there is no problem. Sine 2x is negative 4 times 3, right? Negative 12 over 25 times 2, negative 24 over 25. Now the problem is also asking us to find the quadrant in which double angle is or lies. It's a problem there. I can't simply multiply both sides by 2. Because if I do, I get 550 to 720. But 550 to 720 includes 2 quadrants. So there must be another way. Any suggestions? I have sine, and sine is negative. What else I should determine in order to identify where the angle is? What if I determine you could, but it's easier to find cosine. If I have sine and cosine that are negative, I know which quadrant it is. Which one? Yes, exactly. What if I have sine which is negative and cosine positive? Which quadrant is that? Okay. What if I get sine negative, and these are the only two options, right? Sine, because cosine can be positive or negative. That's how I have to determine it. But since I'm given cosine, when I determine cosine twice x, which of those 3 formulas will I use? I want to find cosine 2x, only because I need to state the quadrant for cosine, for 2x. I'm given cosine. Which of the 3 formulas are we going to use here? We have 3 formulas for cosine of the double angle. I'm given cosine. It would have been 1 minus 2 cosine, 1 minus 2 sine squared, but I'm given cosine. So that would be 2 cosine squared. Exactly. So I plug in 3/5, 2, 9 over 25 minus 1, 18 over 25 minus 1 is negative 7 over 25. Therefore, since sine of 2x and cosine of 2x are negative, I know exactly where 2x is to be found. Which quadrant? In the third, and there is no other option. When it comes to finding the quadrant for the half angle, yes, I will definitely divide all 3 sides by 2. So I divide everything here by 2. Let me write it one more time. 270 degrees less than x less than 360 degrees. I divide by 2, 135 less than x over 2 less than 180. I have no doubts now that x over 2 is definitely in 135 through 180. Second quadrant. So now when I'm asked to find cosine, x over 2, knowing that x over 2 is in the second quadrant, which sign do I pick for this? Exactly. So then I know that cosine x over 2 is negative the square root of 1 plus 3/5 over 2. Why? Because I'm given 3/5. So then it's 5 plus 3, which is 8. So negative the square root of 8 over 5 over 2. So I flip, right? I have 8 over 5 times, this is 2 over 1, times 1 over 2. So then I have negative the square root of 4 over the square root of 5, and this is 2, and I rationalize the square root of 5 with minus in front over 5. Okay. Problem 9. Yes or no? I say yes. Okay, ready?
The tangent makes it so much harder to get something given.
Oh, you're given, no, you're given the legs when you're given tangent.
Oh, right.
That's all.
Yeah, because I
So alpha equals tangent inverse x, which means tangent alpha equals x over 1. That's all you need. So this is your alpha, and you have x over 1. So that's why this is the square root of x squared plus 1. Tangent is even easier than sine and cosine, I think. Okay, ready now? Now, sine inverse y. What is that? Sine inverse y is beta, which means sine beta equals y. Okay? Y over 1, which makes this as 1 minus y squared. So now, I really know that this is tangent alpha plus beta. And I know the formula. Alpha plus 1 minus their product. All I have to do is plug them in. Tangent alpha, I'm going back to alpha. Right here, it's x. Plus tangent beta. Tangent beta is y over the square root. All I have to do is copy them again here. 1 minus x, y over the square root of 1 minus y squared. I will find the least common denominator in the numerator. Square root of 1 minus y squared, that this one is x, the square root of 1 minus y squared plus y. And this one is the square root of 1 minus y squared minus xy over the square root of 1 minus y squared. I don't like doing this because I have to show that I flip it, but I'm fine for now. You know what I mean. Okay, do we have to look at number 10? We have to look at number 10. Is that a yes? Yes? Okay. So we have the left-hand side equals sine x cosine y plus sine y cosine x. Somebody reversed the signs, reversed everything, so be careful. Minus sine x cosine y, but plus sine y cosine x over cosine x cosine y minus sine x sine y plus cosine x cosine y plus sine x sine y. These two go away because they are the same with the opposite sign. These two go away because they are the same and the opposite sign. And the top can be combined. So this is 2 sine y cosine x. The bottom can be combined, 2 cosine x cosine y. And now I simplify factors I'm allowed to. Cosine x with cosine x, 2 and 2. And then I have sine y over cosine y, which is tangent y, which is the right-hand side. Any questions? Is this okay? Yes? Okay, number 11, do I have to show number 11? Is that a yes or a no? Yes? Okay, so you've factored it perfectly. So you had 2 cosine squared x minus cosine x minus 1 equals 0. And you got what? 2 cosine x plus 1 and cosine x minus 1, correct? Minus and plus. Good. So from here I know that cosine x equals negative 1/2 and cosine x equals 1. Well, cosine x equals 1 is not at pi. We talked about that, right? Is at 0. So the only solution here is x equals 0 plus 2 pi k, not pi plus 2 pi k. That over there is negative 1. So if this were negative 1, I would have written pi plus 2 pi k. Is that clear? Now this one has 2 options. One in the second and one in the third. So here, let's look. Reference angle for cosine x being 1/2. And it's not the tiny angle, it's the bottom angle. Which one? Which one is the bottom angle? Pi over 3. So there must be a reference angle here of pi over 3 and a reference angle here of pi over 3. And this is pi. So I go to determine this angle, I go from pi and subtract pi over 3. To determine this angle, I go from pi and I add pi over 3. So then x equals pi minus pi over 3 is 2 pi over 3 plus 2 pi k, and the other one is pi plus pi over 3, which is 4 pi over 3 plus 2 pi k. Is that clear? Yes? Okay. You're going to have equations. Okay? Please remember that. Okay. Find cosine. Almost everyone did 12 correctly, but I'm fine to show it. We did that in class. Lowering the powers I was not happy with. So cosine to the 4th x is cosine squared x everything squared. But you wrote 1 plus cosine x over 2 squared. But that's not true. It's cosine twice x. Right? Cosine squared x is 1 plus cosine twice x over 2. Everything squared. It's the same formula with this. Cosine squared, here. Cosine squared of x over 2 is 1 plus cosine x over 2. Same formula. So now we have to write 1 plus the top squared, 1 plus twice cosine 2x plus cosine squared 2x divided by 4. And you did perfectly. You split it into 1/4 plus 1/2 cosine 2x. That was good. Then I have plus 1/4, but now I have to change this. What do I change cosine squared of 2x into? 1 plus cosine 4x over 2. And that will be the final step. So 1/4 plus 1/2 cosine 2x, 1 over 4 times 1 over 2 plus 1 over 8 plus 1 over 8 cosine 4x. And yes, you have to add these two. So this is 3 over 8 plus 1 over 2 cosine 2x plus 1 over 8 cosine 4x. Okay, last one, extra credit. So 4 sine squared plus 2 cosine squared equals 3. I cannot have 2 trig functions in an equation unless they're factored and so on and so forth. The equation is factored. But I'm happy because I see the squares. So I can change either sine into cosine or cosine into sine. So I will change this using 1 minus sine squared. and distribute 2. So I have 4 sine squared plus 2 minus 2 sine squared equals 3. 4 apples minus 2 apples is 2. Sine squared, subtract, make it 1. So then sine squared equals 1/2, and I have to take the square root. What happens when we take the square root from both sides? Please tell me. Exactly. So sine x equals plus or minus the square root of 2 over 2 because I have to rationalize. And I know exactly which angle that is. So for plus and minus, I have all these points. One pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So x equals pi over 4 plus 2 pi k. Then this one, 3 pi over 4 plus 2 pi k for the positive solution. This one and this one for the negative solution, negative the square root of 2 over 2. So here I'm at 5, and here I'm at 7. Okay, so I consider this a review for that part of the test. Is that okay?